We are live.
Milks is here.
MoNaCo is also here.
Present and accounted for.
We're in our last video of the unit.
Woohoo!
And it's on page 32.
That rhymes. Woohoo and page 32.
Woohoo, page 32.
We're going to put those gas laws to test. The combined gas law, basically.
The one, yeah. We talked about how there was Charles' Law, Boyle's Law, Avogadro's, Gay-Lussac's.
They really are these individual laws
that they kind of like used algebra, bro, to combine. And
right.
As a result, we get the combined gas law, P1V1 over T1 equals P2V2 over T2, and we are going to teach you how to use it
today.
Yeah.
That's it. So, number one, things to remember. Here it is. There's the big bag combined gas law.
PVT, P2V2T.
Yes. Main rule. When we use this is not delta T.
No.
It's absolute T.
Absolute.
So every temperature must be in Kelvin.
Right. Because imagine the scenario where you're at 0 degrees Celsius for your temperature, and look at temperatures in the denominator. Your calculator isn't going to like you very much if you try to put 0 in the denominator.
That is a very good logistical approach, right?
I mean, there's a real that to me is one of the main reasons why you got to be in Kelvin.
Well, the other thing is that 0 degrees Celsius is the freezing point of water, but it still has heat.
Right. And not only that, but if you go to below Celsius 0, you go negative, you get a negative number showing up in your algebra, bro.
Right.
And that's not going to be the scenario.
Sure. Well, when we talked about Kelvin in general, Kelvin is about all energy.
Mm-hmm.
You know, all thermal energy.
And this
not
law
just
relates thermal energy to pressure and volume for
there we
gas.
go.
So we got to be in Kelvin.
Good. The nice part about the other units is we can use any pressure or volume units we want as long as they're the same on both sides of the equation.
So I could throw Torricelli's in there?
You could throw Torricelli's in there. You could throw PSI's in there.
Higgins?
Yeah, you could throw the
millimeters of mercury. You mean it's not Higgins? No.
You're funny.
Higgs.
It doesn't matter the volume either. The volume could be in milliliters, could be in liters. It doesn't matter.
It could actually even technically be in an English unit, like ounces, but we don't want to do that.
Yeah, we don't want to do that.
We're not throwing you those curveballs.
No. And we're not going to make you convert.
No.
I'm not going to give you milliliters on one side and liters on the other.
We're going to be consistent with liters for volume.
Yeah.
And KPA and Pascal,
and
atmospheres for pressure. I think that's what we were consistent with. Yeah.
Right. So we'll be consistent in that regard. But eventually we might make you convert Celsius to Kelvin here.
Mm-hmm.
Beware.
Towards the very end of the practice.
Beware.
And we're going to throw you 3 examples. So finding the final temperature given the final pressure and volume. So this is algebra, bro, which means that you're going to be given 5 of the 6 variables at play.
Sure.
You're just trying to find the last one using algebra, bro.
So who's doing that? There's 3 of them. So who's doing 2? You or me?
Maths are totally your thing, and I'll let you do it. So
cool. I'm doing
you need to write this problem down while we solve it. So you got a problem to write down. It says the volume of a sample of gas at 273 Kelvin and 5 atmospheres of pressure is 150 milliliters. If the volume is decreased to 100 milliliters at a pressure of 3 atmospheres, what is the new temperature of the gas? So Mr. Milks is going to box up all and label all the things we already know, the variables that we already know. So we should start with the initial conditions.
Right, and I'm going to use that decreased 2 to realize that those are the final conditions.
Right, so this
that
is
helps
a lot of reading comprehension.
That helps me understand who my initial conditions were. Is that okay?
Yep, so let's find our ones. Our pressure 1, volume 1, temperature 1. Temperature 1, 273 kelvins. Pressure 1, 5 atmospheres. Volume 1, 150 milliliters.
Can I go ahead and plug those right in now?
You could put those in on the left-hand side of an equal sign in blue.
All right, so it's P1, V1.
So 5 atmospheres, or 5.
Can I leave it at 5?
Sure, we'll throw the units out here, and we'll use our reading comprehension to get our final units.
Over T1.
Over 273. And it's in Kelvin, so we're already good to go. And now we'll switch colors to red, maybe, for our final conditions. So we know the volume decreased to 100 milliliters, so that's volume 2, V2. Pressure of 3 atmospheres, that's P2. And what is the new temperature of the gas? So temperature, that's going to be X or T. Keep it as T, is fine.
I'm going to keep it as T, absolutely.
Cool. So let's plug our numbers in and we'll see what we got.
Pressure is 3
times
100
milliliters
over
T.
which is T2, which is X. So if you've ever had to solve for X in the denominator of a algebra problem, that's really what we're doing here.
It is.
So Mr. Milks, how are you going to go about doing your maths here?
All right, so this math is not what I'm going to show you the real fast shortcut to.
Right.
This math I have no choice, really, but to go the long way. Because of this equal sign, I'm allowed to do your favorite, which is
Cross
multiply.
Yeah.
That really is, let's be honest, it is your favorite, I know it is.
Yeah, so let's draw that equation over again after the cross multiplication is heard.
That gives me
5.
50. I like to keep my numerator right there.
It would be nice if you catch your atmospheres as 5 instead of 50. There you go. Equals 3 times 100 times 273. Now you solve for T2, which is like X on the left side.
Right, so now you have your choice. You can probably multiply this right together and get a number.
Yeah. And we can do it at 5 times 150. Jesus. 150 times 50.
750?
750
750
times
so,
T2.
Sorry, so I can divide this by 750
Right.
and divide this by 750.
Right.
That's going to cancel, and I'm going to get
T2 equals 3 times 100, 300 times 273 equals divided by 750, 109.2 Kelvin.
Kelvin.
Kelvin is our answer there. Okay.
Temperature, Kelvin.
Okay. So since y'all know how to cross multiply and solve for X in a straight up example, after this step, we're not going to solve the problems all the way through. We're going to get you through the cross multiplication step, but you got to solve for X.
Okay.
Because there's a lot of practice, and that's what you're going to be doing the whole time.
Okay.
We'll help you see through the cross multiplication, but the rest is on you.
Okay, good. I'm personally looking for that where I can show you the shortcut and how to multiply. I'm excited. Let's see if it happens. So next one. I got you. Final volume. We're going to try and find the final volume. I have a gas that has a volume of 4 liters at 346 Kelvin and 2 atmosphere. What will the new volume be if? So there's my key. The new volume is everything else after is going to be new, right?
Yeah, so I had to write my equation over again because I'm like that.
I'm with you. And then so everything you just did in blue now is going to have to be my initial stuff.
So 4 liters is my volume. So I got 4.0 liters times pressure 2.0 atmospheres divided by temperature 346.
Oh, look at him. Look, he said I didn't have to put in the units, but guess what? He did it anyways.
I did.
That's how we're conditioned. We
I'm
really
a nerd,
are.
right?
I really like to keep my units in too, believe it, to be honest with you. All right, so what are my final conditions as far as the problem goes?
What will the new volume be? New volume B, well, that's going to be X or B2. We're going to solve for that. That's what we want to know.
Yep.
Temperature's changed to 273 Kelvin. Well, that's
Yep. 273 Kelvin and drops to 1 atmosphere. So those are my P2 and T2. So now let's plug them in.
P2, 1.0 atmosphere times B2, which is X in my scenario. That's how I do my math. I always change my variable to X because that's familiar to me. Okay. And then temperature 273. So if you do the magical, mysterious, wonderful cross multiplication here, you get this. So remember, cross multiply. Get the new equality.
Okay.
4 times, and now I'm dropping my units out.
Okay. Okay. So it's going to be 4 times 2.
Times 273.
There you go.
Equals.
I got you.
1 times X times 346.
Okay,
1
good.
times X times 346. Solve for X, and we know our units for X are going to be volume. And our original units for volume were liters, so we know our answer's got to be in liters.
Did you guys hear that?
Hope so. Let me say it again. We're solving for X, in this case, which is volume. Our original units were liters, so our final units have got to be liters.
Right. Now, just mathematically, just for those of us that are listening and not bumping, how am I mathematically, algebra, going to get X by itself?
I'm going to divide both sides of this equation by 1 times 346.
Which is 346.
Right. So divide the left-hand side by 346, you get X by itself. Sweet. Units are liters.
Cool.
All right, Mr. Milk's
Last
turn.
problem.
The last problem for you to write down is a 20 milliliter sample of gas at STP. Oh, I'm glad we put that in there.
Yeah, Brody.
Is heated to 398 Kelvin.
Okay.
What is the final pressure if the final volume is 100 milliliters?
All right,
so
let's start labeling this up. I have
volume 1 and
P1.
got him.
P1 and T1 are hidden
Yeah.
because standard temperature and pressure
R
is 0 degrees Kelvin. I'm sorry, 0 degrees Celsius. I misspoke. And 1 atmosphere.
1 atmosphere.
And 0 degrees Celsius in Kelvin is going to be
273
Kelvin.
Again,
Excellent.
you can't use 0 because it will mess the calculator up.
I needed to be out of Celsius and into
Into
Kelvin to make this happen. So now in green, I have my initial conditions.
V1 is 20 mils.
Okay, so I'm gonna go
P1 is 1
So
atmosphere.
it's 1 atmosphere times 20 mils
Divided by 273 Kelvin equals final volumes and pressures. 398 Kelvin is T2. Final pressure,
We don't know.
we don't know, so P2, okay, or X, however you want to put it in. And the final volume, 100 milliliters.
So now it's P2, V2.
So
And
P2
I like to know that I'm solving for P2 personally, so I like to keep it in.
times 100 mil divided by 398 Kelvin. Oopsies. Squeeze an 8 in there, kiddos. 398 Kelvin. And so then we get you through the cross multiplication steps.
All right, good. So here's where I'm going to show you how to do it in one step, just to give you another way to do the algebra. So we do know when we do fractions, right? If I look at the right-hand side in red, instinctually, if I want to do this stepwise, if I want to get rid of 398 on the right-hand side, wouldn't I multiply both sides by 398?
Yeah.
And then I can envision I'd be left with the 100 and the P2.
And you divide both sides by 100.
Right. So this comes into what's called the reciprocal. I can multiply by the reciprocal of that fraction. Ready? Watch this.
Oh, yeah.
I can multiply this side by
398 over 100.
over 100.
And
If I do that,
since it's an equality,
this 398 cancels,
right?
and this 100 cancels and leaves me with my P.
But since it's an equality and algebra,
Whatever I do to one side,
you got to do to the other.
So let me go over here and say, now this is going to have to be times that same equation, or same fraction, 398 over 100.
And then your answer would be whatever your math on the left-hand side, 398 times 1 times 20.
Yep, so I'll rewrite this for you, but this is how you're going to do it in your calculator now, right? You're going to say,
Parentheses.
you're going to say 398 times
1.
I don't need
See?
I'm going to lose my units here. Times 1 times
20
divided
over
by
100 times 273 equals P2.
Equals P2. And we saw pressure as atmospheres in our
So
original.
our final answer will be
So P2
equals
equals
blank
some
atmospheres.
And you guys are going to plug and chug that. And here's the trick. Ready? If you in your calculator put in 398 times 1 times 20, you have to hit enter.
Before you do the next part.
And I personally put the denominator in parentheses because it makes life easier. Otherwise, you got to do times 100 equals, divided by 100 equals, and then do again, divided by 273 equals. The fastest, most efficient way to do these problems is just like that.
Yeah, and if you know how to use your calculator properly, you could do it all in one line with parentheses. But that's not math lesson. This is chemistry lesson. And we have finished the unit. Woohoo! You'll notice we didn't do all the practice in class.
No, we did a bunch of the different kinds.
Selected examples.
That give you the spectrum of the possibilities. So we modeled how to do one. At this point, we figured now you should be able to do them.
But mister, you didn't do all the examples for me.
Because
that's the point now.
Yeah, you're not doing enough.
You've got to take what you've learned and saw in the notes, in the bell work, in the mini lectures in class, and step up the game. But mister, you didn't do that in class. You don't. I must not have to do that page.
Wrong.
We are still expecting you to try your hardest at every example in our packets.
Seriously.
And step to the plate, grade yourself, check your answers, because that's real learning.
Yeah, my kids know in my class, right, that the answer key is available.
And you got to check yourself.
Show me that you did it.
Yourself.
Show me that you did it first, and then you can check and make sure you did it right.
Yeah.
And honestly, you can check and see if I made any errors. And I'm cool with that.
Yeah, or, you know, and you correct yourself, because that's true learning. I made a mistake, risk-free.
Okay, good.
Now don't do it again.
I'm really not concerned if you make a mistake. I'm concerned if you learn from it so that on the test, you crush it.
I'm going to second that motion. But you still, in order to pass our test, you got to do it all.
Yeah, that's the only way to get it, guys. This is applied math, and your math teacher makes you do this lessons, the homework over and over. You got to take that new task, that new skill you learned. You got to practice it a few times to kind of get it right.
Yep.
Right? You practice it not till you get it right. You practice it till you can't get it wrong.
Thank you. And that's why we put so many extra practice pages in that we didn't hold your hand through.
Right. Well, we already modeled you one. At this point, you're just a zombie. If you just need to,
Well, you chug it.
I mean, if you need to write everything I write, that's me doing too much.
Right.
Next slide.
Oh, there's another slide?
Yeah, a bye-bye slide.
Bye-bye.
There you go. We learned the relationships. Now you need to be able to put some numbers in so we can predict what is that final temperature going to be? What is that final volume going to be?
Yeah.
And we have the ability to do that now.
Yes. So now you have a basic understanding of the behavior of matter, heat, transfer, measuring heat in different physical changes and chemical changes.
Sure. And two huge definitions we changed this particular unit, right? Boiling and temperature. Well, heat.
Heat, yeah. You also know now how a gas behaves and how the conditions can change the behavior of a gas.
Very good.
Our next unit is all about solutions.
Sure. Yeah. Good. So it kind of like put
Not
stuff in
mathematical
liquid.
solutions.
We'll make some Kool-Aid, bro.
Dealing things with liquids.
Yeah.
Aqueous, the AQ really matters next unit.
Yeah. Very good. See you guys.
Thanks. Bye.